Topic 1.4, Sustainability. Previously, what we've been doing in Topic 1 is learning how to model systems, inputs, outputs, storages, and transfers. The reason why we're doing this, and later on we'll talk about feedback loops to also model these systems, is we're trying to come up with a model that's sustainable. And what we mean by sustainability is that your input matches your output, and that you don't have too many storages get depleted along the way. So what is sustainability? Well, it's a proper use and management of resources that allows for replacement. So we don't take too much out, we give it time to go ahead and replenish. Later on, we'll refer to these things as renewable resources. So an example, I suppose, in Oregon is how we cut down timber, trees. Used to be a big industry in Oregon. Deforestation. If you go ahead and cut down too many trees, you don't give the trees time to regenerate. It takes about 20 years for a generation of trees to replace. If you go ahead then and do clear cutting, you really eliminate the possibility of that happening. And more appropriate design would be to do randomized cuts and then replace them with seedlings, so you give it time. So there's two things we want to talk about here to define how a system could be sustainable. First of all, what are we starting with? The natural capital. These are actually resources that you have. So if I was talking about a forest, the trees would be a natural capital. Might also be mineral deposits in the forest. I could also, I suppose, talk about the animals and plants, other plants within the forest as being natural capital. What I get out of the forest would be natural income, goods and services provided by the natural capital. So I could cut down trees and then reform the wood into lumber. That would be something. Or there may be crops, other crops that I could harvest from the forest. Berries, syrups, minerals. And I could fashion those into things. It doesn't always have to be products, by the way. It could be services. So the forest could be used for camping or hunting. That would also be a natural income that I could get from it. So now we're seeing that when you put these things together, the models that we worked on previously in Topic 1 become a little more complicated here. So we have natural capital, that's what we're starting with, and natural income. And you can see you create a loop here to get an income, get a yield from it. And we want this loop to be sustainable. But you can see that oftentimes you have loops here which are not sustainable, where you're extracting more than the annual yield that's coming into the system. So we don't want any of these to be depleted. We want it to be sustainable. How do we go ahead and get a sustainable loop? Well, you could have economic development, such as making energy systems efficient. You could have social development, such as getting some sort of cultural diversity. You could have environmental protection, and there's been a number of times where the United States and other countries have come together to do environmental protection. The Brundtland Report in 1987 was one such attempt. Another attempt was the Millennium Ecosystem Assessment. This was also done by the United Nations. You don't have to remember all these parts here. It's pretty obvious what they were trying to do here. The United Nations in 2001 was looking at unsustainable use of natural resources, came to the conclusion that 60% of the world's ecosystems are being degraded. Not a good thing. This results in lack of biodiversity, and they came up with a bunch of ideas to stop this from happening. So what were their ideas? Whole bunch of goals here. Eradicate poverty, that would help. Empower women, that would help. Kind of a laundry list, really, of things that would force countries to be more sustainable, improve healthcare, reduce child mortality. The good news about this agreement was that 189 nations signed on here. I suppose, why wouldn't you sign on? It's like being against motherhood and apple pie, I suppose. But of course, the goals were probably idealistic. Very hard for countries to reach these goals, and as we'll discuss later on, the pros and cons of international agreements. It's hard to enforce them. What are you going to do if a country doesn't really follow the agreements here? In a more local sense, though, in the United States, we try and enforce these goals by doing what we call environmental impact assessments, or sometimes they're called statements. Essentially, if you're going to do any sort of major building project, you probably have to file an environmental impact assessment. In other words, is it going to be sustainable, what you're doing? Is it going to cause irreparable harm to the area that you're working in? It's quite a complex procedure, but if you were building a school or a new factory, or if you were building a road, you would have to file an environmental impact assessment. It requires a lot of planning to do, but it aids in the development, and we can watch how your project is coming along here. And it gives us an idea of what to expect long-term from your project. Most importantly, trying to minimize the damage done to the environment. Let's take an example of a project that would conduct an EIA. Let us suppose I'm building some sort of pipeline or some sort of factory or storage facility. You can see that people might be concerned if there was leaks from here. It might get into the river here. We might be concerned if there was pollution. Looks like we're generating something over here. If there are houses nearby. We might be concerned, this looks like it's an LNG facility here, liquid nitrogen gas. Explosions would definitely be a problem. Is there an evacuation procedure in plan? So what's the process here? Well, it's a pretty involved process here. You first of all start by conducting a baseline study. Then you go ahead and predict what the positive and negative impacts of your proposed development are, what the possible impacts on life and the environment would be, and ways to reduce negative impacts from your project. And then the candy part, what's the economic benefits? And then nobody comes up with a complete list which is all positive. Always good to have some negatives there and ways to mitigate those negative aspects. Makes for a better discussion. So let's summarize what an EIA is. In other words, it's a way to support sustainability, to have environmental protection and to have loops which can go on and be sustainable. It integrates protection and economic into its planning. It predicts what's going to happen, and it tries to mitigate any adverse impacts there. In order to do this, it has to work with public and government agencies. You're part of a system, and we want to know what you're up to. Now, what are the weaknesses of EIAs? Well, different countries have different standards. In the United States, we may have very strict protection laws, and maybe some people think our laws are too strict. There's too much red tape involved in things. Where's going to be the boundary of your impact zone? So if I look back on that factory, that storage facility I was just building, is it just the immediate area or the entire city? If it's close by a river, does that mean that it affects the whole state? Where do we draw the line? It's very expensive. You have to hire people who really know what they're doing, and it takes a long time to do an EIA, especially if it's a major facility here. It's just a model. It may not work out exactly the way you plan it to work out. Now let's go ahead and talk about ecological footprint, EF. Very fashionable term these days. This is a definition you should probably know for the test. The amount of land and water a given population requires to produce all the resources that people consume and take away and all the waste they make. In other words, in the United States, to maintain my standard of living, how much land and water resources do I need? In the United States, we have a pretty high standard of living, so we require a lot. So our ecological footprint is high. Now, again, it doesn't mean that we have more resources. It doesn't mean that we have more land and water than other countries. It simply means that we need to use more of it to maintain our higher standard of living. The space required to support all the inputs and outputs of the population. So this is getting back to our idea of how we modeled a system. What are the components of an ecological footprint? Well, growing crops, growing food, and we've become far more efficient in the United States at growing crops. We produce far more food than we need, so that has helped to maintain our high ecological footprint. Same thing goes with grazing animals. We've moved over to feedlots, for example, in cattle instead of free-range grazing. Harvesting timber, we've gone to, unfortunately, clear cutting, which cuts down a lot more timber in order to maintain the lumber that we need. We've increased our technology in how we catch fish. It's not just guys going out there with fishing poles anymore, is it? And we've built up a very large infrastructure which allows the movement of goods and services around the country here. Finally, we found ways to absorb carbon dioxide emissions burning fossil fuels. Unfortunately, many of these ways are not particularly good. We've put in a lot of carbon dioxide into the air, and later on when we get to topic 6, we'll talk about the problems that came with that. So where are we now as far as ecological footprint? Well, you can see, wow, how the ecological footprint has been increasing throughout the world here. 156% of biocapacity, that means it's not a sustainable system here. We're using far more than we can replenish into our storages. We're overshooting on our ecological footprint. When humanity's ecological resources demands exceed what nature can supply, what we take out in output as compared to what's going in input, we have ecological overshoot, and it's not sustainable. What we have seen as an example is what's happening with carbon. We are putting too much carbon into the air too quickly, and that has caused massive problems. Extinction of animals, deforestation, loss of groundwater, and so forth. The human footprint is growing too large. It has more than tripled since 1960. Later on, we'll talk about ways we can mitigate this problem.